All right, as you can see, the title today is going to be Oxidation and Reduction. Here you see a very useful tool that I have shared for many years with many of my peers and even some of my individuals that I have helped along the way. So here we have what I consider the hierarchy of oxidation and reduction. So we're going to go and look first at any oxygens, and if there were any oxygens, noting if there were any changes to them. If there were no oxygens, I would then look at hydrogens for any increase or decrease. If there was no hydrogens or no change to any hydrogens in my equations or problem, I would then look for my charge. Did my charge go up or down? So here you see a series of arrows. So if we're dealing with oxygen and there was an increase in the number of oxygens in my compound, then I know an oxidation has occurred. If it has reduced in oxygen, it has been a reduction. Uh, Now, if we think about oxygen, if something has had oxygen added, it has oxygenated. So think about it, it is under this oxidation column. Now let's look at hydrogens. This is where many people are familiar with oil rig. Oxidation is loss of hydrogens, and reduction is the gain of hydrogens. Then, of course, we look at our charges. If there's an increase in charge, we are going to have an oxidation. If there's a reduction in our charge, then we'll have a reduction, okay? So our first three examples are going to be kind of simple for the ones that we have, and then we'll have a little more complex one that will add a couple more terms that we have not seen for our other two or three examples. So first we're going to look here, and we have H2O has now changed to H3O. So looking at our first item in our hierarchy, we look for any oxygens and have there been any changes. So on the reactant side, I have one oxygen. On the product, I have one oxygen. So nothing has changed with my oxygens. So I must then go down to my second level, which is hydrogen. Here we have two hydrogens, and that has now changed to three hydrogens. So according to our chart, if we have had an increase in hydrogen, what type of reaction has occurred? So here we are. We didn't have a decrease. We had an increase. So it went up in hydrogens. So we have had a reduction occur. Okay, let's look at our second example. We have Fe3 plus has now changed to just Fe plus 1. So I have no oxygens this time. I have no hydrogens this time. All I have is Fe or iron. So we've gone from 3 to 1. So have we increased or decreased? We've gone from +3 to +1. So we have gone down in charge. So we have also reduced yet again. Okay. And now our third example, we're going to have F2 or difluorine or difluoride. And now we have OF2. So right here, we can automatically see that we've gone from a singular element to a compound that has another element. And that element this time just so happens to be oxygen. So according to our chart, if we have an increase in oxygen, it falls under the oxidation column. So F2 actually participated in an oxidation. Okay? So take a moment, copy these couple of examples and your chart down, because you're going to want this chart when we do our next set of looking at a full chemical equation. All right. So you may be asked not only which of your species is reducing, but you may also be asked about the agent. So I want us to think about one, our agent is going to be on our reactant side of our equation. But in order to determine what our agent is, we have to determine who has oxidized and who has reduced. So if we look here at our first compound, we have Cl2 with a neutral charge. And then we have Cl2Cl with a negative charge. So if we have a decrease in charge according to our chart, because in this equation we have no oxygens and no hydrogens, so we know we're dealing with just our charges. So if we look at Cl2 with a neutral charge has now become 2Cl with a negative charge, he has actually decreased in his charge. He's gone from 0 to -1. So we know a reduction, okay, a reduction has occurred, okay. So then we look at Br, or 2Br negative, has now become Br2 with a neutral charge. So it went from -1 to 0. So from -1 to 0, that is definitely an increase. So there we have oxidation occurring. So now we need to take a look and determine which is the agent and which one is the reducing agent and which one is the oxidizing agent. I want us to think about the job of an agent in our normal world. The agent is the means by which someone is discovered, or it is the means by which something happened. Okay? So I'm going to repeat that. The agent is the means by which something has happened. So without this person, you may have never been discovered as a musician or an actress or an artist. So think about, because of this thing, this was able to occur. Okay? So because of the presence of a particular substance or person in the sense of the talent agent, because of that person being there, this was able to happen. So let's take a look. So much like in some of our acid-base problems, I'm going to draw some circles and squares around the items that I want to compare. Okay? So here I know I'm comparing my Cl2 to my 2Cl negative, and I am comparing my 2Br negative to my Br2. Okay? So let's look at this in the sense of what I just stated that an agent is. An agent is the reason something was able to happen. So if we look at Cl2, we know that a reduction happened once we arrived at our reactant side of our equation. But because of this one being able to reduce, it allowed my other compound to oxidize. So because Cl2 was present, Br negative was able to oxidize. So for my Cl2, even though it was a reduction, he is going to be my oxidizing agent. Okay? Because of his presence, my Br negative was able to oxidize. So because Cl2 was on the field, saw what Br was doing, it aided him in being able to oxidize. The same thing has happened here with the relationship of Br negative and Cl2. Because Br negative is present, it allows Cl2 to reduce. So this one would be considered my reducing agent. Okay? So we have our species that was reduced and our species that was oxidized. Okay? So this would be our species reduced, because between our Cl2 and our Cl negative, we are able to see that that reduction happened. So that is going to be my species that reduced. My species that reduced. All right. And then once again, we're comparing our Br negative to our Br2. And we know that once we get to the product side of this, that then would be my oxidized species. So he is the person in the equation who oxidized. Okay, and because of his presence, our other item was able to reduce, and vice versa. So once again, I thank you all for tuning in, and I hope that these small yet kind of long videos iron out and kind of fill in some of those gaps in some of the material that you're having difficulty with. So once again, happy studying, and I wish you the best of luck.